Captions in English, please. So this is the 8th video on chapter 7. And we will look at oxidation reduction reactions. So reactions that involve the transfer of electrons are called oxidation reduction reactions. And to do short, we call them redox reactions. Redox reactions are responsible for the rusting of iron, the bleaching of air, or the production of electricity in batteries. All reactions that involve the reaction of oxygen are also redox reactions. So let's look at some fun examples to watch. Here we'll look at those one by one. And so the first one is the reaction of a gummy bear. So let's look at another one. It's called elephant toothpaste, and the reaction is summarized here. It's hydrogen peroxide becomes water and oxygen. And another example, the carbon snake. So as you can see, oxidation reduction reaction can be quite impressive. So which element is oxidized, which is reduced? Because when you have an oxidation reduction reaction, you have both an oxidation happening and a reduction happening at the same time. You cannot have one without the other. And so oxidation involves the loss of electrons. reduction involves the gain of electrons, and so that's why they have to happen at the same time. Some elements will lose electrons and another element will gain those electrons. And so to help you remember this, because it is something you need to remember, there are some helpful mnemonics here. Oil rig, oil for oxidation is loss, and rig for reduction is gain. Leo ger, lose electrons oxidation, gains electrons reduction. So try to remember those mnemonics so that you can remember which is which between the oxidation and the reduction. So a reaction can be immediately classified as a redox reaction if it meets any of these requirements. So redox reactions are those in which a substance reacts with elemental oxygen. So whenever oxygen, O2, gas, is a reactant, it's considered an oxidation-reduction reaction. When a metal reacts with a non-metal, that's also for sure a redox reaction. And more generally, when a substance transfers electrons to another substance, that's when you have a redox reaction. So let's look at an example. 2 magnesium solid reacts with oxygen gas to form 2 magnesium oxide solid. So the magnesium is gray silver metal. It reacts with oxygen from the air, and you need a flame. You need to start the reaction with a flame, and it will burn and give the magnesium oxide, which is a white powder. So which element is oxidized and which is reduced? So you have to find what is the oxidation state for each of the elements in that reaction. And any element in its natural state will have a 0 charge. So when you have magnesium as a solid, this is magnesium in its natural state. So it will have an oxidation state of 0. Oxygen, elemental oxygen is O2, a diatomic molecule made of 2 oxygen atoms, and it's in the gas phase. And that's also oxygen in its natural state. So it will also have a 0 charge. Now for magnesium oxide, this is an ionic compound because it's made of a metal and a non-metal. And if we look at what ions they are made of, what makes this compound, which ions it is. We know that magnesium from group 2A makes a 2+ ion, and oxygen from group 6A makes a 2 negative ion. So that's the charges for magnesium and oxygen in magnesium oxide. So we can see that magnesium goes from an oxidation state of 0 to an oxidation state of 2+. So if we write this, we have magnesium becomes magnesium 2+. And so when magnesium becomes the cation magnesium 2+, it's because it has lost 2 electrons, right? So loss of electrons is oxidation. So then magnesium, the solid, the elemental magnesium, is oxidized into magnesium 2+, the cation. So we say that magnesium is oxide because it lost electrons in this reaction. Now, if we look at oxygen, it started from a state of 0 in its natural state and becomes -2, the oxide. If we write this as a half reaction here, oxygen, the atom of oxygen, if you give it 2 electrons, it becomes the oxide ion, O-2. So we see that oxygen has gained electron in this reaction. It goes from 0 to 2- state. So that means it's reduced because it gained electron. So that's how you determine which element is oxidized and which element is reduced. So notice here when we write those half reactions for magnesium by itself and then for oxygen by itself, the electrons will be on the right side of the arrow for oxidation And on the left side of the arrow for reduction, because reduction is gain of electrons. So you add the electrons to the reactant and it gives an anion, or not, or else it can become zero, a charge of zero if it was positive first. And then for the oxidation, for the half reaction, the electrons will be on the right side because they have been lost. So you remove them from the reactant. Let's look at another example. Cobalt, solid, so it's a metal, plus 2 HCl aqueous, that's hydrochloric acid. So if you put a piece of cobalt metal into hydrochloric acid, you get COCl2, an aqueous solution, plus H2 gas. So you will see a formation of bubbles from the hydrogen escaping as a gas. And you form ions of copper and chloride that combine together to make the COCl2 compound here. So which element is oxidized and which element is reduced? So let's find out the charge for each element here. So we said that elements in their natural state or elemental state have a zero charge. And here we have cobalt in its elemental state. That's a metal, it's a solid. And we have also the hydrogen gas. Hydrogen in its elemental state is H2. It's one of those 7 diatomic molecules. So these two are zero charged. HCl, if you look at HCl, even though it's made of nonmetals only, it's a molecular compound or a covalent compound. It behaves as ionic. It's like an ion in solution. And it forms the H plus ion and the chloride ion. So H will be a positive one in this compound, and chloride is the negative one ion there. When they become cobalt 2 chloride, the cobalt here is a cation with 2 positive charges, and then the chloride is still the same with 1 negative charge, because that's an ionic compound. So, thinking of what ions are making up this compound, you can find the charge. So cobalt goes from a state of 0, oxidation state of 0, to an oxidation state of 2+. So if we write this for cobalt, we have cobalt by itself with no charge becomes cobalt 2+, and plus 2 electrons that have been taken out from the cobalt in its natural state. So cobalt here is losing electrons, so it's oxidized. The cobalt metal on the reactant side is oxidized. Be careful, it's not the cobalt 2+ that is oxidized. It's the cobalt in its natural state that becomes oxidized when it becomes CO2+. And so we've seen that the chloride stays as -1, from left to right. And so the other element that changes is the hydrogen. It goes from a state of +1 to a state of 0. So H+, when it's in solution, HCl gives H+ ions. If you give it an electron, it becomes H in its natural state, so with a 0 charge. So H in HCl is reduced because it gains an electron to become, the H2 gas. So you may be confused here on how we find out the charge on the elements. You want to treat covalent compound as if they were ionic to determine the charge. For ionic compound and for elements in their natural state, it's a given. Elements in their natural state have 0 charge. Elements in their ionic compounds have the charge of the ions, the corresponding ion. But for covalent compound, you take the formula as if they were ionic and find out their charge this way. However, these numbers are fictitious. They are only a way to keep track of the electrons, right? When we, except for acids in this case here, HCl is an acid and it will behave as if it was ionic when it's in solution. It will give away H plus ions and Cl minus ions. But here in hydrogen peroxide giving, decomposing into water and oxygen. So what element is oxidized, what element is reduced? Here to find the charge. So again, oxygen as O2 gas is in its elemental state. So that's going to be a state of 0. Water, so water is a covalent compound. So to find the charge of the ions, think that of oxygen when it's an ion and H when it's an ion, and H is typically H plus and oxygen is O minus. So the charge on the hydrogens and the oxygen in water will be, +1 for the hydrogen and -1 for the oxygen. -2, sorry, for the oxygen. But in H2O2, you have 2 oxygens and 2 hydrogens. The hydrogens are still H plus there, but you have 2 hydrogens with that means 2 positive charges in total. So each oxygen will have to share the 2 negative charges and become a -1. So the oxygen in H2O2 is only charged with 1 negative charge. So because you keep the principle of the formulas being neutral overall, they have to be neutral overall. So that's also a guiding principle on how to find the charge on the elements. So we see that hydrogen stays the same from left to right of the arrow. Oxygen, there is one oxygen that becomes, from -1 to -2. And so for that oxygen, from O -1, gaining an electron will make it O -2. And so in water, it's O -2. So that oxygen is reduced because it gained an electron. By gaining an electron, it becomes O -2. And then we see that there are 2 oxygens in hydrogen peroxide. And so the other oxygen that was a -1 on the left side becomes oxygen with a charge of 0 on the right side with O2 gas. And so for that oxygen, O -1 here becomes O with one more electron, with 1 electron. The oxygen has lost the electron. So now it's the oxygen in its 0 charge state plus 1 electron that has been, lost by the O -1, oxygen. So for that oxygen, it is an oxidation because it loses electron. It lost an electron to become the oxygen in its 0 charge state. So that oxygen is oxidized. So you see how the 2 oxygens from the hydrogen peroxide, H2O2, become, different kind of oxygen afterwards. So let's practice this. It requires a lot of practice for you to master this. So which of the following are oxidation reduction reactions or redox reactions? And if it is a redox reaction, which element is oxidized and which element is reduced? So you have all these examples. And I want you to pause the video and try this on your own, because it's only if you try on your own that you will start to learn. So let's go over the first example. We have zinc as a metal, solid, plus CuCl2 aqueous solution gives zinc Cl2 aqueous plus Cu solid. So whenever you have a metal, if you look at your periodic table, any kind of element that is a metal, from the left side of the staircase, when it's just by itself in its elemental form and it's a solid because it's a metal, that's the elemental form for the metal. So zinc and copper in this reaction will be in their elemental state and will have 0 charge. Now let's look at CuCl2. It's a ionic compound because it's made of a metal and a non-metal. So you can find the charge from the ions there are in those ionic compounds. CuCl2, the chloride ion has one negative charge, you know, it's an halogen, or has one negative charge. You have two chlorides, so that's two negative charges in this formula. So the copper in this formula will have to be Cu2 plus. So it's Cu2 plus and then Cl minus. In the zinc chloride, it's the same, right? Because chloride is still one negative charge. You have two chlorides, so two negative charges in total. So the zinc here will have to carry two positive charges to cancel those two negative charges. So we can see that zinc goes from a state of 0 to an oxidation state of 2 plus. So we can write the half reaction for zinc here, and it's going to be zinc becomes zinc 2 plus plus 2 electrons. Those electrons have been plucked out of zinc so that it becomes a cation. Because those electrons are lost by zinc, we say that zinc is oxidized. Zinc, the metal one, the solid one, the reactant, right? So zinc is oxidized here, and then copper, we see how copper has become from a 2 plus ion, it becomes the elemental copper, you know, Cu metal with 0 charge. So if we write the half reaction, it's going to be Cu2 plus 2 electrons gives Cu. Right, we need to give 2 electrons to the cation Cu2 plus so that it becomes an electrically neutral Cu. And so it has gained electron. The Cu2 plus has gained electron, so the Cu2 plus is reduced.